I'm just going to give you a little bit of explanation on both these programs. So, first of all, your program where the robot moves in the clockwise direction, that is how the clock moves, is almost perfect. So, that's good job. So here I see you make the robot move for 52 centimeters, then it turns to the right, creating an outer angle of 150, pauses, moves in the opposite direction. But again, let's look at this. If you use a speed of 3, the robot's going to take too much time to move. So maybe we should use a little bit of faster speed, because then the program itself, when it is creating such a big angle, um, it will it'll be too slow. And remember, we have only 150 seconds to complete the missions, so we are going to go a little bit faster here. So it creates an angle, then there is of course a lag, um, sometimes and then you are correcting the lag at with speed of 3 is perfect. These steps are perfect. Now your robot is traveling 60 centimeters for 3.41 rotations. That's good. You did you off the motors here? Let's see here. Of course, you need to have the motor stop here. Give it a little bit of pause after that. So I'm going to add these steps. um, Motors off, let them pause a little bit. Again, these are not wrong what you've done, but this would make the uh, program more precise. So this is good. Again, every time when a robot changes a function, you want to just try to pause it a little bit. You could do 0.1, you could do 0.3. Now your robot is traveling this way, and you have to off the motors, always off the motors here. So again, not a big deal, but it's always better to make the EV3 pause and give it all the right functions. Now again, so it has traveled here, it is moving to the right. Let's increase the speed a little bit to 30. And then it is creating an outer angle of 120 with an inner angle of 60. Great, good job. It's correcting itself at this slow speed. Motors are off. So these steps are perfect. And like I said, this is an almost perfect program. Now it's moving 30 centimeters. Again, remember we off the motors. Here, so let's off the motors again. And then pause the robot. And like I said, you could do it for 0.1, you could do it for 0.3. Sometimes I've seen the 0.3 works better. So now your robot is traveled in this direction. Again, when you create the initial speed is 30, it travels positive 90, then stops, corrects the lag, and comes back to the same positions, and motor stop. Great job. So just a few changes, and the program is almost perfect. Now here is where there seems to be a little bit of confusion. So you're creating a program that is moving in a counterclockwise direction. Let me see another thing which you have done here or you haven't done here. Okay, so here there is another problem. So you reset the gyro the first time, correct? Now your robot has moved forward. It has created this angle of 150, and then it is moving forward. Now before it starts turning, you want to reset the gyro. That's otherwise, if it has turned 150 like this, and what is it comparing this angle to? It gets very confused. So we have to reset the gyro before each angle. So we're going to do it here. We're going to reset the gyro. And of course, pause. Every time you reset gyro, pause. Okay. The same thing now, it's going to move forward, and before you make this turn, you're going to reset the gyro. If you don't reset the gyro, robot gets extremely confused. It doesn't know what it is comparing the angle to. And every time you reset the gyro, you pause. So let me just go through this whole program again. So if I just full screen this, that'll be a little bit easier. So we reset the gyro here. Well, maybe if I just go back to the what I was, because then I have the triangle here. Okay, so the robot is starting here. It's facing to the left, and it is moving forward 2.95 rotations. The motor stop, it pauses, turns to the right, creating an outer angle of 150 with an inner angle of 30, pauses again, corrects the gyro lag. Okay, and then it moves forward 3.41 rotations. The gyro has to be reset again, otherwise it doesn't know what it's doing. So you reset the gyro, creates an outer angle of 120 with an inner angle of 60, corrects the gyro lag. Then it moves forward 1.7 centimeters. Of course, reset the gyro, otherwise you won't be able to create this 90 degrees angle. So create the 90 degrees angle, you correct it for the gyro lag. Maybe we missed a block here for pausing the motors, because otherwise of course the motors will never stop, and then you stop the motors here. Perfect.